Hey, it looks like I'm going to send you 2 videos today. Something weird happened with my computer. So, yes, we're just going to pick up right where we left off. So what I was saying is the path doesn't matter. The change will still happen with potential and kinetic energy, okay? So it doesn't matter if something's dropped or if it slides down or something like that, okay? So turn the page to 260. Look at the loss of mechanical energy. So as we know, like oscillations of a pendulum, they eventually stop. A bouncing ball eventually stops. The height of a roller coaster hill gets lower and lower. So where does the mechanical energy in such systems go? An object moving through the air experiences the forces of air resistance. In a roller coaster, there are frictional forces in the wheels. When a ball bounces, the elastic potential energy stored in the deformed ball is not all converted back into kinetic energy after a bounce. Okay, in each of these cases, some of the original mechanical energy is converted into thermal energy within members of the system, and as a result of the increased thermal energy, the temperature of the objects in the system will slightly rise just a little bit. So we'll study this type of energy in chapter 12, okay? So let's look at the conservation of mechanical energy in our practice problem, okay? Let's see, let me get my ducks in a row right here. Okay. So our strategy that we're going to use, look at the problem solving strategy on page 260. It says, when solving conservation of energy problems, use an orderly procedure. This always helps me when I'm doing problems and things like that. So carefully identify the system, make sure it's closed and there's no objects that enter or leave. Okay. Identify the initial and final states of the system. Is the system isolated? If there are no external forces, then the total energy of the system is constant. So E before would equal E after, like we talked about. If there are external forces, then E before plus W equals E after, okay? So then identify the forms of energy in the system. If mechanical energy is conserved, then there is no thermal energy change. If it is not conserved, then the final thermal energy is larger than the initial thermal energy. So decide on the reference level for potential energy, which we talked about last time. And don't draw bar graphs. I don't really care about that. Okay, so let's look at the practice problem. On page 261, a large chunk of ice with a mass of 15 kilograms falls from a roof 8 meters above the ground. So part A says, ignoring air resistance, find the kinetic energy of the ice when it reaches the ground. And then B says, what is the speed of the ice when it does reach the ground? Okay, so we know our mass from the problem, 15. We know our height is 8 meters. We know gravity is 9.8 meters per second squared. We're looking for K1. Oh no, sorry, K1 is 0, because remember it has no kinetic energy because it hasn't been dropped yet, okay? So K1 is 0, and UG2 is going to be 0, because remember it changes from potential energy to kinetic energy. So what we're looking for is our UG1, so the potential energy first, we don't know that. We're also looking for the kinetic energy when it reaches the ground, so that's K2. And then we are also looking for the velocity when it reaches the ground, okay? So first, we need to find the potential gravitational potential energy, right? So we have the UG1 is equal to mass times gravity times height, okay? So all you got to do is plug in. Mass is 15, gravity is 9.8, and height is 8. Okay, And you end up getting 1.18 times 10 to the third joules. Let me write that down. .18 times 10 to the third joules. Okay, and remember before when it was 20 joules of potential energy at the beginning, it becomes 20 joules of kinetic energy at the end. So therefore, UG1 is equal to K2. So we know the kinetic energy of the ice when it reaches the ground because we know the gravitational potential energy at the beginning. So K2 is also equal to 1.18 times 10 to the third joules. If that's a little confusing, go back and look at what we went over just a second ago on the previous page, okay? So the whole reason we had to find the gravitational potential energy at the beginning is so we could find K2. Okay, and now that we know K2 and the mass, we're going to be able to find the velocity because of our kinetic energy formula, which is K equals 1/2 mass times velocity squared. Okay, you just have to switch up the formula a little bit. Okay, so we're just going to take that 1.18 times 10 to the third joules and put it into our kinetic energy equation. But if K2 equals 1/2 mass times velocity squared, just some rearranging will give you V equals the square root of 2 times kinetic energy over mass, okay? That's just the rearranging of it, okay? Okay, and now you just have to plug in. So velocity is equal to the square root of 2 times 1.18 times 10 to the third joules over the mass from the beginning, which is 15 kilograms. All right, and when you solve for that, you get 12.5 meters per second. Okay. All you gotta do is know your formulas here, and it's pretty simple. Okay, great. I hope that makes sense. All right. Okay, that's all we're going to go over today. We're going to look at analyzing collisions tomorrow. I'm going to give you homework today, though. Practice problems on page 261. Do 9 and 10 all. So I think there's A, B, and C. There's A, B, C, D on 9 and A, B, and C on 10. I'll go over those tomorrow before we start analyzing collisions and how kinetic energy is lost during those collisions. Yeah, like I said, I hope y'all had a good break and y'all are ready to push through to the end because y'all are so almost there. It's going to be great. Sorry again for the 2 videos. I don't know what happened. But yes, I will see you all tomorrow. And actually, my last week at Chick-fil-A is next week because they're doing remodeling. So if y'all want to Skype starting in April, I should be able to do that. It doesn't work great on my computer, but it might be better to do that than just having to sit here and listen to videos from me all the time. So just let Coach Reese know what you all think about that, and he will relay that back to me. And like I said, I'm going to give you a spot where you can talk about things that are working and things that aren't working on your next test, which will be Friday. And it'll just be like a standard test that we usually have, so don't freak out about it. And yeah, y'all have a good rest of your day, and I will see you tomorrow.